module, you will learn about the use of a transistor as an application device, such as a switch and an amplifier. You have learned that when the emitter terminal of a transistor is common to the input and the output, the transistor is said to be in common emitter configuration. For a transistor in common emitter configuration, the forward-biased emitter-base junction forms the input circuit, where the input voltage is VBB, while the reverse-biased collector-emitter junction forms the output circuit, where the output voltage is VCE. We shall try to understand the operation of the transistor as a switch by analyzing the behavior of the base-biased NPN transistor in the common emitter configuration. On applying Kirchhoff's voltage rule to the input of the circuit, we get VBB is equal to IB into RB plus VBE. Let this be equation 1. And on applying Kirchhoff's voltage rule to the output of the circuit, we get VCE is equal to VCC minus IC into RC. Let this be equation 2. Here the input voltage VBB is represented with VI and the output voltage VCE is represented with VO. Then the equation 1 can be written as VI is equal to IB into RB plus VBE. Let this be equation 3. And the equation 2 can be written as VO is equal to VCC minus IC into RC. Let this be equation 4. Let us now discuss the change in the output voltage, VO, with the change in the input voltage, VI. In case of a silicon transistor, the cutoff voltage is 0.6 volts. As long as the input voltage, VI, is less than 0.6 volts, the transistor is in the cutoff state and the collector current IC is 0. Then, from equation 4, the output voltage VO is equal to VCC. When the input voltage VI becomes greater than 0.6 volts, the transistor goes into the active state. In the active state of the transistor, the collector current IC increases linearly with increase in input voltage VI. Then, the output voltage VO is equal to VCC minus IC into RC. The output voltage VO decreases linearly till its value becomes less than 1 volt. Beyond this, the transistor goes into the saturation state. That is, with further increase in input voltage VI, the output voltage further decreases to 0 but never becomes 0. In the saturation state of the transistor, the collector current IC is maximum. Let us now discuss about the transistor as a switch. When the input voltage VI is low, the transistor is in the cutoff region. In the cutoff region, the collector current IC is 0 and it is not conducting. Then it is said to be switched off. If the input voltage VI is high enough to drive the transistor into saturation state, the output is low and very near to 0, and the collector current IC is maximum. Then it is said to be switched on. Let us now discuss about the transistor as an amplifier. To discuss the transistor as an amplifier, we use the active state of the transistor. In the active region of the transistor, the output voltage, VO, decreases linearly with an increase in the input voltage, VI. If delta VI and delta VO are the small changes in the input voltage and the output voltage, then the ratio of the change in output voltage to the change in input voltage is called small signal voltage gain. That is, AV is equal to delta VO by delta VI. Let this be equation 5. When the input voltage VI is at the midpoint of the active region, then the circuit behaves as a common emitter amplifier with voltage gain AV. This voltage gain AV can be expressed in terms of the resistances in the circuit and the current gain of the transistor. We know that the current gain of the transistor, beta AC, is equal to delta IC by delta IB. Let this be equation 6. From equation 4, we can write the small change in output voltage, delta VO, is equal to 0 minus RC into delta IC, which is equal to minus RC into delta IC. Let this be equation 7. Similarly, from equation 3, the small change in voltage delta VI is equal to RB into delta IB plus delta VBE. But delta VBE is negligibly small in the circuit. Then delta VI is equal to RB into delta IB. Let this be equation 8. On substituting equations 7 and 8 in equation 5, we get AV is equal to minus RC into delta IC by RB into delta IB. Let this be equation 9. On substituting equation 6 in equation 9, we get the voltage gain of the amplifier as AV is equal to minus beta AC into RC by RB. Thus, the transistor in the active region can be used as an amplifier. You have now reached the end of this module. In this module, you have learnt that depending on the input and output voltages, a transistor exists in 3 states, namely cut-off state, active state, saturation state. A transistor in the cut-off state does not conduct and acts like a switch in the open or the off position. A transistor in the saturation state acts like a switch in the closed or the on position. In the active state, a small increase in the base current causes a large corresponding increase in the collector current, and the transistor acts like a power amplifier. The voltage gain in an NPN transistor amplifier in the common emitter configuration is given by AV is equal to minus beta AC into RC by RB, where beta AC is the current amplification factor, RB is the resistance in the input circuit, and RC is the resistance in the output circuit.